This is Algebra 2, Unit 12, Lesson 8 on the normal distribution and z-scores. Now, there are many different normal distributions, each one depending on two parameters, the population mean, which is the mu, and the population standard deviation, which is the sigma. All right, rather than performing computation on each new set of parameters for a variety of normal curves, it is easier to work in reference to the simplest case of the normal curve, which is the standard normal distribution, which is the bell curve, the one that looks like this. That's the bell curve. All right, so the process of converting a value from a normal distribution to a value for the standard normal distribution is called standardizing and requires the use of z-scores. So basically a z-score is a standard score. It's a measure of position that represents the number of standard deviations a given value x falls from the mean. So basically what it's saying is you can find any value on here how far away it is away from the mean by using the z-score. We don't have to use one standard deviation, two standard deviations. We could use 1 1/3 standard deviations. We could do 2.7 standard deviations. That's what your z-score is measuring. So the z-score is positive if the value lies above the mean. And the z-score is negative if it lies below the mean. So if we were to draw a sketch here, our basic standard deviation, this would be the mean. All right, and then you would have +1 standard deviation this way, and then -1 standard deviation this way, and then +2, and so on. That's with the normal curve that we usually see. All right, here's -2, and so on and so forth. Well, what if we had a value that fell right here? Okay, that would be somewhere between 0 and 1 standard deviations, not necessarily a half, so this could be the z-score. All right, so the z-score here, for example, could be 0.3 z-score. That would be a z-score right there. So it is 0.3 standard deviations away from the mean because it's positive. All right, now over here on the left-hand side, if it's away from the mean, the z-score would be negative. Because, so for example, if I put one right there, if I was looking for that value right there, that could be like a negative 1.7 z-score. So there we go. So we can see what the z-score is when we're doing that. So when you're doing a z-score, what you're looking for is the distance away from the mean. It doesn't have to be 1, 2, it can be whatever distance that you want. And we use that to calculate some percentages in just a second. All right, so the formula for calculating a z-score is when you have a z-score, it's whatever point you're at is x, is your point you're looking for. This is the minus the mean, and then divided by the standard deviation. Okay, so a population has a mean of 24.8 and a standard deviation of 4.2. Find the z-score when. All right, so let's take a look at what we have here. We have an x equals 30. So if I plug in, if I want to find the z-score, I want to figure out x is 30 minus the mean, which is 24.8, divided by the standard deviation, which is 4.2. Okay, because this is mu, this is the standard deviation. All right, so 30 minus 24.8 is 5.2 over 4.2. And if I divide that out, I get about 1.24. So the z-score is going to be 1.24. So what that means is, if I was going to do the standard deviation, here's my chart right here. Here's my mean. This score of 30 is 1.24 standard deviations away from the mean. All right, now remember the mean in this case is 24.8. All right, the standard deviation is 4.2. So if I did 4.2 here, one standard deviation, 4.2 added to 24.8 is 29. Yeah, that's right. Okay. So if the x is 30 is right here, that's actually 1.24 standard deviations away from mean. That's how far this is away from the mean. So 30 would actually be right here, and the distance from here to here is 1.24 standard deviations, which is the z-score. Okay, now let's look at x equals 19. All right, so the z-score is going to be 19 minus 24.8 divided by 4.2. And when I divide that, I get negative 5.8 over 4.2. So let me divide that out. Negative 5.8 divided by 4.2, which is about negative 1.38. Okay, so this means that 19 is negative 1.38 away from the mean. All right, now since it's negative, it's going to be on the opposite side of the curve. All right, so here is my mean, opposite side of the mean, I mean. This is going to be my mean of 24.8. All right, now minus 1 standard deviation from 24.8 is 20.6. So 20.6 would be 1 standard deviation, which is minus 1 standard deviation, which is 20.6. All right, now 19 actually falls right here. So this is going to be, that's going to be 19, that's going to be minus 1.38 standard deviations. So that's what a z-score is when you're doing these. All right, now what do we use z-scores for? That's what we're going to look at next. Once we know what the z-score is, we can then use to find percentages based on the normal curve using the normal cumulative distribution function, which is normal CDF on the calculator. Okay, so normal CDF is, you find it using second, vars, and then number 2, normal CDF. So let's see what that looks like. Normal CDF. All right, so if I go second, vars, normal CDF, I look at my calculator. If I press second, vars, it's over here next to the clear key. Number 2, don't pick number 1, that's PDF. I want CDF, which is number 2. All right, and then you get this screen right here. Okay, and I'll explain about that screen in just a second. So, what's happening when you do that? Find the probability the variable has a z-score of less than 0.36. All right, now, let's take a look at what that looks like first of all. Okay, so here is my normal curve, and I have my mean is at, right here is at usually 0, and then 1 standard deviation of the mean. It would be over here on this side. All right, so if my z-score is 0.36, which is positive, which means 0.36 away from the mean, which would be right here. All right, so this is 0.36 is my z-score, right there. Okay, now find the probability that a variable has a z-score of less than 0.36. All right, on a normal curve, probability of finding that value is found by area under the curve. That's what the normal CDF measures, normal cumulative distribution function. It measures the area under the curve between points. All right, so a z-score of less than 0.36 would be any score that falls on the normal curve all the way up to 0.36. Okay, so I'm looking for the area of this here. This would be the probability, will be the area that you end up with. Okay, so let's take a look at the normal CDF function. So when you do normal CDF, you have to write down what you are putting in your calculator so the person grading it knows what you did. Okay, now, if we look at the normal CDF, let's go back and remember how to do it again. Second, vars, number 2, normal CDF. All right, now on the normal CDF, you have to have a lower and an upper, the mean and the standard deviation. Okay, so the lower is the lowest point on your graph. So if we look at our problem here, you just need to pick a big number that is on the negative side, because this would be 0 if you're at the mean. All right, so this would be, we can use a negative number, any negative number you want, that it would cover the thing. All right, so that would be your lower, would be negative 1, what did I have here, E99. Okay, we'll just leave that one in there, is fine. So that's a really small number. All right, now the next one would be the upper. Well, where it starts here, where does it stop? Well, it would stop at 0.36. So we would put 0.36 in here. All right, now if we have the mean, we're using just a standard deviation graph. The mean would be 0, and we're going by 1 standard deviation, so 0 and 1 would be our next ones. 0 and 1. And then we go down to paste. right? So that'll put the numbers, that's what we just wrote down. And then you press enter. And you get this weird decimal, 0.6404057, so it's 0.6406 approximately. So about 0.6406. This is the percentage. Okay, so this is going to be 64.06% is that the variable has a z-score of less than 0.36, because that would be the area under this curve. All right, so let's apply these to some actual problems. A normally distributed population, remember this only works for a normal distribution, of test scores has a mean of 80 and a standard deviation of 5.2. Okay, so let me do my sketch. It's very helpful when you do a sketch in these so you can see what you're doing. All right, so my mean is going to be 80. That's going to be 80. All right, my standard deviation is 5.2. Find the percentage of scores that lie below 73. All right, so 73 would be right here. That's my z-score that I want. So I'm looking for the percentage of scores that lie below 73, which would be this area here. All right, so when I do my normal CDF for this one, normal CDF, well, if this is test scores, what's the lowest test score that you could have? Well, your lowest test score would be a 0. You can't get anything lower than a 0. All right, your highest, we want to go only to 73. All right, that's going to be here. And then my mean is going to be 80. And then my standard deviation is 5.2. So that's what I need to put in my calculator. So 0, 73, 80, 5.2. So I go to my calculator, second vars, number 2. All right, so 0, 73. My mean was 80. And my standard deviation was 5.2. And then paste and enter. And I get 0.0891. All right, so that equals 0.0891. So that's approximately 8.91%. So 8.91% of the values fall below 73. Okay, so let's take a look at this one. Find the percentage scores that lie between 82 and 86. All right, so when I do this one, here is my mean, is 80. 82 is here. 86 is here. I'm looking for that area right there. Okay, so when I do my normal CDF, what would be my lower? All right, my lower would be 82. My upper would be 86. So because I'm looking from here to here. My mean is still 80, and my standard deviation is still 5.2. So if I go to my calculator, second vars, number 2. All right, I pick 80 here, or 82, I'm sorry, and then 86. And these stay the same, 80 and 5.2 stay the same. I go to paste and enter, and I get 0.2260 approximately, 0.2260, which is about 22.6%. So 22.6% of the data falls between 82 and 86 when it's normally distributed. Okay, let's look at this one here. All right, find the percentage of scores that lie above 73. All right, so here's my mean is 80. 73 is over here on the left side of the mean, so that's over here. Above 73 would be up to the mean and then all the way over to here. So normal CDF. All right, I'm going to start at 73, and the highest score I could get would be 100. Okay, and then 80 and 5.2. All right, so I go to my calculator. Second vars, normal CDF. All right, I'm starting at 73, but this time I'm going to 100. 85.2, paste, and I get about 0.9108, which is 91.08% of the scores. Okay, so there I go. All right, so that is normal CDF on the calculator. We'll save the last one to do for practice and the last question. So you're going to need a calculator when you do this on your homework.